JWST represents an entirely new era in cosmic observation. As the first telescope of its kind with the power to rival and even surpass previous instruments, the JWST has captured the imagination of scientists and space enthusiasts alike. Despite its hefty price tag and years of development, the JWST is already making waves with groundbreaking discoveries. One such discovery, however, has stunned researchers and might just change the way we understand the universe: the warp bubble. But what exactly is a warp bubble, and what has JWST uncovered about this strange and exciting concept so far? Space, the final frontier, is an infinite and ever-expanding expanse that beckons us with untold secrets. Within it lie galaxies, black holes, nebulae, and countless exoplanets. It's a vast and awe-inspiring place, full of phenomena that we are only beginning to understand. For centuries, humankind has been driven by curiosity, seeking to expand our knowledge and answer fundamental questions about our existence. What lies beyond our own planet? Could there be alien civilizations out there, watching us just as we study the stars? Or is there a chance we have already discovered microbial life on distant exoplanets? The pursuit of these answers pushes humanity to explore further into the unknown. Yet, the challenge of exploring the vastness of the universe is no small feat. Consider the distance to Mars, a mere stone's throw compared to the infinite stretches of space that lie beyond. While Mars may be the closest planet capable of supporting human life, even getting there is no easy task. Volunteers for Elon Musk's ambitious Mars colonization project will endure a grueling journey of over 5 months, crossing the hazardous void of deep space. And that's just Mars. If we attempt to travel further, say to Proxima b, the closest exoplanet to Earth, things start to seem nearly impossible with current technology. Proxima b lies 4.24 light-years away, or about 25 trillion miles from Earth. To put this into perspective, a light-year is about 5.88 trillion miles. The current technology we have simply isn't equipped to cover that kind of distance in any practical time frame. But even with these staggering distances, humanity hasn't given up on the dream of reaching distant stars. Thanks to space telescopes, we've found a way to explore faraway cosmic objects, even if we can't physically travel to them. One of the most iconic of these telescopes, the Hubble Space Telescope, has revolutionized our understanding of the universe by providing us with breathtaking views of galaxies, nebulae, and stars that are billions of light-years away. Hubble has acted as our cosmic window, bringing distant regions of space to life, but now, with the arrival of the James Webb Space Telescope, the bar has been raised even higher. JWST is poised to surpass Hubble as the most powerful observatory in space, offering us the ability to peer deeper into the universe's past. This telescope is 100 times more powerful than Hubble, and with its unmatched sensitivity, it allows astronomers to study the cosmos with unprecedented clarity. By studying distant stars and galaxies, JWST is able to transport us back in time, all the way to the birth of the universe itself. But how is this possible? How can we see events that occurred billions of years ago? The answer lies in the nature of light itself. Light from distant stars and galaxies takes billions of years to reach Earth, and as such, when we observe them, we are essentially looking back in time. Light from these stars, traveling across the vastness of space, serves as a time capsule, revealing the appearance of these objects when the universe was still young. NASA has already released some awe-inspiring images from the JWST, showcasing the telescope's incredible capabilities. One such image is of the Carina Nebula, a cloud of gas and dust where massive stars are born. These stars are many times larger than our Sun, and yet, they are just a tiny part of the vast, star-forming region. Another breathtaking image shows the Stevens Quintet, a group of 5 galaxies, 4 of which are locked in a complex gravitational dance. As these galaxies pull at each other, their shapes are warped, creating a mesmerizing cosmic spectacle. And that's just the beginning. JWST has also captured incredible images of galaxy clusters, such as SMACS 0723, where the gravitational pull of the cluster has warped the light from distant galaxies behind it, allowing us to observe far-off cosmic objects that would otherwise be invisible. But what really has researchers on the edge of their seats is something far more mysterious: the discovery of the warp bubble. So, what exactly is this phenomenon, and why is it so important? At its core, a warp bubble is a theoretical concept that could allow faster-than-light travel. Instead of traveling faster than light in the traditional sense, a spacecraft inside a warp bubble would essentially surf through space itself. The space in front of the bubble is compressed, while the space behind it is expanded. This creates a bubble of space-time that moves faster than light, carrying its contents along with it. This concept challenges everything we know about the limits of space travel, and could have profound implications for the future of interstellar exploration. Why is the idea of warp bubbles so significant? The concept addresses one of the most vexing problems with faster-than-light travel: time dilation. In theory, if we could travel faster than light, time would slow down for the traveler relative to those left behind. This means that a journey that could take hours for the traveler might feel like years on Earth. This could lead to all kinds of paradoxes and complications. However, warp bubbles don't have this issue. Because the space inside the bubble doesn't change, time remains unaffected for everyone, no matter how fast the bubble is moving. This makes warp bubbles a potentially viable solution to the problem of faster-than-light travel, without the side effects of time dilation. The idea of faster-than-light travel isn't just a modern concept, it's a staple of science fiction, most famously in the Star Trek franchise. Since the first episode of Star Trek aired in 1966, the concept of warp drive has captured the imagination of millions of fans around the world. Star Trek's crew travels from planet to planet at speeds that exceed the speed of light, exploring distant worlds, meeting alien civilizations, and exchanging messages across the galaxy. The warp drive is an essential part of this future technology, allowing humanity to explore the far reaches of space without being hindered by the vast distances between stars. In the real world, however, it was long believed that warp drive was purely fictional, something that would remain a fantasy. But in 1994, physicist Miguel Alcubierre proposed a startling new idea: a warp bubble could, in theory, make faster-than-light travel possible without violating the laws of physics. Alcubierre's idea was based on the concept of compressing space in front of a spacecraft and stretching it behind. The spacecraft itself would remain inside a bubble of flat spacetime, which would allow it to move faster than light without breaking any physical laws. However, there was a catch. Alcubierre's theory required something called exotic matter, a form of matter with negative mass that has yet to be discovered. This posed a major challenge to the concept of warp drive, as negative mass is a theoretical idea, and no one knew how to create it. That is, until Dr. Harold White, a researcher at DARPA's Eagle Works laboratory, and his colleagues stumbled upon a remarkable discovery. While conducting an experiment on the Casimir effect, which relates to the distribution of energy across wavelengths, White's team unexpectedly found a way to create a real nanoscale structure that could potentially generate negative energy density. This breakthrough opened up a new avenue for warp bubble research, and White began refining Alcubierre's original concept. By using this newfound understanding, White was able to propose a revised model for a warp drive that drastically reduced the energy requirements and made the idea of a working warp drive seem far more plausible. Now, instead of relying on exotic matter, White's model suggests that a practical warp drive could be created using materials and energy that we may one day be able to manipulate. The concept has been informally dubbed the Alcubierre White Warp Drive, and it has sparked renewed hope among scientists and sci-fi enthusiasts alike. While much more research is needed before we can develop a fully functional warp drive, White remains optimistic that small-scale warp-capable spacecraft could be built and tested within the next few decades. Could humanity one day be able to travel across the galaxy at faster than light speeds? It may sound like something out of a Star Trek episode, but the potential for real warp bubbles has never been closer to reality. While we may still be years or even decades away from seeing this technology in action, the progress made so far has brought us one step closer to the stars. So, what are your thoughts on warp bubbles? Do you think we will one day be able to travel faster than light? Let us know in the comments below. And if you enjoyed this video, don't forget to like and subscribe to our channel for more exciting space news and discoveries. Ready to go on another cosmic adventure? Click the video on your screen to continue exploring the wonders of the universe.